Welcome to another edition of Math with Mr. Douglas. Today we're going in the Millennium Falcon and off to a galaxy far, far away as we go and explore similar and congruent figures. Yes, we will be looking at, is Kylo Ren... Wait, there's a spoiler. So if you don't want to know about Star Wars history, you need to skip this and go to the math. But we'll look at, is Kylo Ren similar to his grandfather, Darth Vader? Or are they congruent? We will check that out in the math ahead. All right, are you with me? Here we go. So today we're looking at similar and congruent figures, and we're channeling the power of the dark side. Yes, we're going to be having Kylo Ren and Darth Vader join us. So here's my probably going to be a horrible attempt. If you've done any kind of watching of my videos here, you know how basically horrible my drawings are. But maybe if we have to go and draw Star Wars things, maybe, just maybe, we'll start to see some pretty good drawings here. So here's my little guy. Of course, he's got a crazy lightsaber that for some reason can shoot out the sides and that sort of thing, which when you think about it is pretty handy. But then of course his grandfather, good old Darth Vader, and kind of the key to drawing Darth Vader is to start with what I like to call a like McDonald's sort of thing. So there's McDonald's, and no, this is not going to be sponsored by McDonald's, this whole lesson. But you kind of start doing some like golden arches and then kind of the top of his helmet. You need to add some eyes, of course. And you can make your eyes look all kind of spooky or scary and whatnot. And it's important to get his little triangular mouth. He has a triangular mouth there with the vertical lines. And then some kind of mask and that sort of thing. Now Vader, of course, Vader has the classic red lightsaber, as all Sith people do, and there's his red lightsaber, I guess. And if you get into the whole Star Wars lore, the hilt of a lightsaber is really important. So we got Vader and we got Kylo. And what are we talking about today, though? We're not talking about Star Wars because that would be way too much fun. We're talking about if something is going to be similar or if it's going to be congruent. And we are talking about shapes today. So we're all talking about shapes. And there's some different things that both of these have to have in order for something to be similar or something to be congruent. So that's pretty important. So what is it? So figures that have the same shape are similar. So if you're similar, you have the same shape. Okay, you have the same shape. Great. To be congruent though, you also have to have the same size. So that's kind of the big difference here. Is congruent figures that have the same size and the same shape. So we'll say here they have the same shape and size. Okay, well, obviously Kylo Ren and Darth Vader are neither similar nor congruent, although they're related, but mathematically we can't say that they're similar or congruent. So today what we're going to do is we're going to use some lightsabers to go and make our point, because I thought that would be kind of fun. So here's this lightsaber, and we'll say, there we go. And if I ask you whose lightsaber is that, yeah, there's some different answers you could say, but we're going to say that's Yoda's. That's Yoda's lightsaber. And we'll add some dimensions onto Yoda's lightsaber. We'll say that this one is, I don't know, how big is a lightsaber? 1.5 meters? Does that sound about right? 1.5 meters? And we'll say that the little hilt here is what, 10 centimeters? So 0.1 meters. And then we have Luke's lightsaber, which is kind of like Anakin's, which is kind of like, I guess, Obi-Wan used it for a little bit. So let's go and draw Luke's kind of blue. I guess you could say it's rays now too, I guess. Oh, was supposed to say that. But let's just imagine, because I mean, obviously their lightsabers are going to be bigger because they're just bigger people. And we're just going to have some fun stuff here. Now, this isn't real life, okay? So don't freak out. I'm going to say that this is 3 meters. And I will say that this is 0.2 meters wide. Okay, so there we go. And we're talking about Luke right now. So I've asked you for these lightsabers, is it similar or is it congruent? So similar or congruent. So remember, to be congruent, it has to have the same shape. Are both of these in the shape of lightsabers? Absolutely. Are they the same shape though? Yes, they are. But are they equal in size? Well, if you've seen Yoda before, he's a small little, well, actually he's a small little Muppet basically, but it is not the same size. It's a little bit smaller for that little guy. So for these lightsabers, we would say that they are similar, same shape, but they are not congruent. Okay, so hopefully that kind of puts it into perspective. Whereas, you know, if I said, again, so if I said, like, here's Kylo Ren's lightsaber, and here is Darth Vader's lightsaber, are they similar? Absolutely not. They're not the same shape. Are they congruent? No, because they're not the same shape, so they can't be. So in math, though, we're obviously going to throw in some stuff too. So we're going to throw in, we're probably going to throw in some triangles. We seem to like triangles. And there's definitely some things that we need to know. Now, you can have stuff that isn't kind of rotated a different way, and this is what we're kind of getting into. And what you need to be able to do is kind of line up things. And we like to use these little lines to indicate different angles. So I'm saying that 3s and the 2s, I'm going to make this kind of basic, this one. So if you see, if I just kind of took this and I kind of rotate, if I took this triangle and I kind of just rotated it and kind of lined it up with these different angle markers, that they would be similar, definitely similar in shape. And let's just hypothetically say they're also congruent. So say I said this was 8, this would have to be 8. Let's say I said this was 12, this was 12. And say I said this was 15, and this was 15. Yes, these would be congruent. Congruent. But where do teachers try and go and trick you now? Well, this is how teachers go and trick you. They go and do the following. So they go, say, here, and then they do another one. So these are like my little pizza shapes. Don't get too hungry. And then they're going to go, and obviously they're going to go and add in some markers like this. And what you need to do as a discerning young student is to go and start to figure out, is this actually congruent? So they'll throw in some numbers here, like 4, maybe 9, and maybe, actually, make this 14 and make this 12. Okay, so there we go. And then they go and they do this to you. They do 9, and they say that this is 14 and this is 12. Okay, well, you look at it looks the same shape. Yeah, sure, all the numbers are the same. Awesome, that means it must be congruent. Well, no, you have to go and actually rotate this one. So if I was actually to go and rotate, let's say I went and changed this one. So I'm going to go and rotate it so it's similar to the other one. So I'm going to go and make it like this. And when I do that, so I don't know, this is the thing where you need to kind of be able to visualize this. So this is always interesting when this happens. So when you go and kind of rotate everything, what actually happens? So this was 3 and then this was 2, like that. Let's go and put in the numbers. Let's go plug in the numbers. So between the 1 and the 3 angle, between the 1 and the 3, so between the 1 and the 3, if I was to go and basically kind of rotate, oops, I'm sorry, did I do this wrong? I did this wrong. Sorry, this should be, let's go back a step. Let's go and fill in these angles properly. Okay, sorry about that. So I'm rotating these ones, and I want to make this one like this. So I'm just kind of basically flipping it. and I would go and make this one and then these two. Like that. Okay, now we're good. Let's go and add the numbers in now. So between 2 and the 3, so between the 2 and the 3, what was there? There was 14. And between the 1 and the 2, was 12. And then here, between the 3 and the 1 was 9. Just like that. So you actually have to go and do that. Now, if you're kind of looking at this and saying like, oh, okay, well, then that's fine. They're absolutely. Well, are they? So I've gone and changed all the numbers. That's great. But have you noticed a difference between this triangle and this triangle? Have you noticed? Have you noticed? Have you noticed? Well, in reality, is that between the 3 and the 2 is 14 here, but between the 3 and the 2 is 12 here. Uh-oh. So the angles aren't matching up, and the numbers aren't matching up. These are neither similar. This is not a congruent. Now, they might be similar in shape, but they are not congruent. They are not the same size. So it's important that you, in your mind, you're able to kind of go in and wrap your head around that. Okay, so that's kind of getting at the similar and congruent stuff for you guys. And what this is going to lead into is going to be scale factor. So what we really want you to kind of be able to do is to go and basically visualize stuff today. That's kind of what we're wanting to do. So we can get some really good kind of questions. Like, let's say I went and said to you that the following two figures, they are congruent. So they are congruent, and I said find the unknown. So let's just say I had this as a triangle, and I said that this was a double angle, this is a one angle, and I said this is 4, this is y, and this is 8. And over here, okay, I got 6, and this is 4, and this is x. And the different angles are going to be 2 and 1. Okay, so I wanted to say, what is going to be the angles here. Now, can you see that in my mind, I'm kind of just going to be turning this around this way. So imagine I just flipped it over on this point, kind of flipped it over. Can you see what's kind of happening? So if I was to go and do that, if I went and actually flipped it like that, then all of a sudden, so if I went and did that, then this would be the double, this would be the single, and then over here would be the 4. Over here would be the 6, and this would be the x. So what would everything be? So y would equal the 6, and x would equal the 8. Now, sure, you might be able to just do that one. Like, that's absolutely no problem. Well, we start to do things with more complicated shapes, which you get more probably practice from your math teacher in. But that's the idea of how you want to be kind of thinking about things, is lining up the angles, making sure everything's rotated all nicely, and then moving forward from there. Sound good? Awesome. So if I go and I tell you, though, that I say a few figures, they are similar. So I'm telling you that they are similar. So that means they have the same shape. And then I say, go and find me x. So say this was 8 and this was 6. And I say this was 20 and this was x. Just like that. Okay, well now we can go and make our proportions. So we would say stuff like, and this is important. So you see how I did 8 and 6? Over here, I would say 20 and x. Okay, so I'm going to go and do that kind of thing. So I do my cross multiplying. So 8x is equal to 120. If you're like, whoa, what just happened there? Remember, I went and I just cross multiplied like this. So how many times can 8 go into a 120? I think is it 15? I always get my 15 times tables mixed up. I think it's 15 though. So x is going to be 15 like that. So that's how you're going to be if you're told that these are similar. So remember, we were told that these are similar. So you can always go and do your cross multiplying and go and find some things just kind of like that, which is pretty important to be able to go and do. One other thing that we can talk about in terms of similar figures. So similar figures, they also have ratios that are equal between side lengths. And that's a really useful thing to do or to know. So if we're saying, like, for instance, like here's your friendly little rhombus, and we're saying that there's a similar rhombus. So we have a little rhombus there, we have a little rhombus there, but we're saying that they are similar. I'm telling you, these are similar. Okay, they are similar. That's awesome. So what is the ratio? So I want to know, what's the ratio? And remember, what are ratios again? They're just fractions, okay? So we're just comparing a couple things. So you've seen them like this. You can also see them as like literally as a fraction and that sort of thing. So for this one, I mean, I'm making it pretty obvious. So if I had to compare them, it would be 6 to 4. 6 to 4. And of course, we'd go and we'd simplify this to 3 over 2. So we would say that would be kind of like the ratio, 3 to 2. Of the perimeter. But if I said, what's the ratio of the area? Well, is it the exact same thing? Well, remember, area is always going to be squared, right? Squared. This now says squared, squared. That's weird. But if I said it's squared, so what's that going to be? Well, it's not going to be 3 to 2. It's not this. We actually have to go and square it. So the ratio of the area is actually 9 to 4. That's what we would say. So the ratio is 3 to 2 for the perimeter, but 9 to 4 for the area, because we always square area. So there you go. So that's kind of using similar figures and ratios to go and figure some things out.
Thank you, all you math and Star Wars fans, for checking us out today. You can go and subscribe. You can go on YouTube and check out some more awesome Star Wars stuff. Whatever you want to do, have a great day. Thank you again. Until next time.